Hi guys, today we're going to look at molar gas volumes, how you convert from moles to a gas volume and back again, and we're also going to apply this to some problems. So firstly, in the exam, so in the IGCSE Chemistry, if you turn to probably the back page, you're going to find a periodic table. And right underneath at the very bottom of the periodic table, you'll notice this one statement here. And it says the volume of 1 mole of any gas is 24 decimeters cubed at room temperature and pressure. Now Cambridge, they'll only ever use this, that either 1 mole is 24 decimeters cubed at room temperature and pressure. They won't change that. That is it, and it's there in the, it's so important, it's just there as a statement by itself right underneath the periodic table. Now, if you've got moles and you want to convert it into a gas volume, you're going to times by 24, because there's 24, so 1 mole is 24 decimeters cubed. So how many moles you've got here, you're times by 24, and then going backwards, if you're given a gas volume, you're going to divide by 24 to get back to moles. Okay guys, so what I've got here is a battle plan of how we are going to solve these problems. They could give us a mass volume, they could give us a mass, but either way we want to get up to moles here. Now, if they give us a gas volume, we'll divide by 24 to get to moles. If they give us a mass, we'll divide the mass by the molar mass. That will tell us the number of moles. Then we'll look at the chemical formula and we'll look at the ratio. So that's the next part. We're going to deal with the ratio. Then we're going to find out how many moles we're looking at. Then if they want a mass, we'll times by the molar mass, and if they want a gas volume, then we'll times by 24 to convert it back into a volume. What volume of oxygen is required for the complete combustion of 11.5 grams of sodium? Okay, so they've given us sodium here. We're going to try and find out the volume of oxygen. So they've given us a mass. So the mass is 11.5 grams. We want to go up to moles here, so we're going to firstly divide by the molar mass, which is 23. Okay, and we get 0.5 moles. Then we're going to look at the ratio. Well, it's a 4:1 ratio, and we're looking for oxygen, so it's a 4:1, so 0.5 times by 1 divided by 4. That's going to tell us how many moles of oxygen we're going to have. So we have got 0.125 moles of oxygen, and then the question is looking for a volume, so we're going to do our little trick of timesing by 24. So that's it, times this by 24, and we get 3 decimeters cubed. There we go, that's our final answer. What volume of carbon dioxide gas is produced from the complete thermal decomposition of 500 grams of calcium carbonate? So we're starting off with a mass of 500, and we want to know how many moles we've got. So we want to work out, well, what's the molar mass of calcium carbonate? Well, calcium is 40, carbon is 12, and then we've got 3 times by 16. Add these all up together and we get 100. So 500 divided by 100 is 5 moles. If we look at the ratio, it's a 1:1 ratio. That makes life nice and easy. So 5 times by 1 divided by 1, well, that is just 5. And then finally, to work out the volume, we're going to times by 24. So 5 times by 24. So our final answer is 120 decimeter cubed. And that is our final answer. What mass of calcium reacts with 72 decimeter cubed of oxygen? So this time we're starting off with a volume. So we're going to do 72 decimeters cubed. And we want to work out how many moles we've got. So 72 divided by 24. This is going to tell us how many moles we've got. So 72 divided by 24. And we get 3. Now let's have a look at our ratio. We've got oxygen here, that's 1, and then the calcium here is 2, and this is the direction that we're going, so it's a 1:2 ratio. So 3 times by 2 divided by 1 is 6. Now calcium on the periodic table has got a molar mass of 40, so we're going to do 6 multiplied by 40. That's going to tell us our final mass. So 6 times by 40 is 240 grams. That is our final answer. What volume of hydrogen gas is produced when 2 grams of calcium reacts with water? So we've got 2 grams of calcium. Okay, we want to know how many moles we've got. Well, calcium on the periodic table is 40, so this is what we're going to have to do. 2 divided by 40, and we get 0.05 moles. Okay, now we're looking at hydrogen, so it's a 1-to-1 ratio. Okay, so 0.05 times by 1 divided by 1, well, that's nice and easy, 0.05. Okay, then finally we want to know what's the volume, so we're going to times by 24. So 0.05 times 24, and we get a volume of 1.2 decimeters cubed. What volume of chlorine is needed to react with 1.12 kilograms of iron? Okay, so firstly let's just convert that into grams. So that's 1,120 grams. Okay, now we've got 1,120 grams of iron, and we want to know, well, how many moles have we got? Well, iron on the periodic table is 56, so 1,120 divided by 56. This is going to tell us how many moles we've got. So 1,120 divided by 56, we've got 20 moles. Now, if we look at the ratio, it's a 2-to-3 ratio. So 2 to 3. So we're going to do 20 times by 3 divided by 2. So 20 divided by 2 times by 3, and we get an answer of 30. So we've got 30 moles. We want to know the volume of the gas, so we're going to times that by 24. So 30 times by 24, 30 times by 24 is 720 decimeters cubed, and that is our final answer. What volume of oxygen reacts with 510 grams of ammonia? So we've got 510 grams of ammonia. We want to know how many moles have we got. Well, nitrogen is 14, and we've got 3 hydrogens, which is 1 times by 3. So the total molar mass of of ammonia is 17. So 510 divided by 17, that's going to tell us how many moles we've got. We've got 30 moles. Okay, now let's have a look at the ratio. We want to know oxygen, and it's a 4-to-5 ratio. Okay, so 30, okay, we're going to times by 5 and divide by 4. That's going to tell us how many moles of oxygen we've got. So 30 times by 5 divided by 4, we get 37.5 moles. And then finally you want to know, well, what's the volume? So we're going to time this all by 24. So 37.5 times by 24, we get 900 decimeters cubed. And that there is our final answer. What mass of potassium bromide reacts with 3 decimeters cubed of chlorine? Okay, so we're starting off with a volume of gas this time. So we've got 3 decimeters cubed. How many moles have we got? So 3 divided by 24. 3 divided by 24, we have got 0.125 moles. Okay, now that was chlorine, and it's a 1-to-2 ratio with potassium bromide. So 0.125, okay, times by 2 divided by 1. That's going to tell us how many moles of potassium bromide we have. So we've got 0.25 moles. Then we just need to work out, well, what's the molar mass? Well, bromine is 80 and potassium is 39. Which when we add 80 plus 39, the total molar mass is 119. So lastly, we just need to times by 119, and that's going to tell us our final mass. So 0.25 times by 119, and we get 29.75 grams. Okay, and finally, what volume of carbon dioxide is produced when 1,000 centimeters cubed of propane is burnt in a large volume of oxygen? Well, 1,000 centimeters cubed is 1 decimeter cubed. Okay, so we've got 1 decimeter cubed of propane. Okay, so 1 divided by 24, that's going to tell us how many moles we've got. And we've got 0.0416 recurring. Now let's have a look at the ratio. We want to know is what volume of carbon dioxide, so it's a 1 to 3 ratio. So what we want to do is 0.0416 times by 3 divided by 1. Okay, and we get 0.125 moles. And then we're looking for carbon dioxide, and it's a volume. So remember, it's any gas you times by 24. So just times this by 24, the number of moles, and we get 3 decimeters cubed. And that is our final answer.
Don't forget to subscribe.